In this video, we're going to do another couple of examples of finding a derivative using implicit differentiation. And when we say find dy dx by implicit differentiation, as this problem says, that's what we've done. So to start with, maybe you want to hit pause and try to solve each of these on your own, and then check your answer against my work. Before we actually take the derivative, let's go ahead and look at the graph real quick. It's an unusual looking function, very periodic, but definitely not a function, failing the vertical line test all over the place. So as before, I'm going to start by making my substitution, saying y is equal to f of x, and then eventually we're going to replace any y prime and f prime of x. So we're going to have 4 times the sine of x times the cosine of f of x equals 1. Now we're going to take the derivative of both sides of this equation. And on the right, we have something nice and easy. The derivative with respect to x of 1 is just going to be 0 because it's a constant there. And on the left, we're going to have to work a little bit harder. In fact, we have a product rule happening here. So I will think of 4 sine of x as one function and cosine of f of x as another function. So let's leave the first function alone, and we get 4 sine of x. And now we need to take the derivative of the cosine of f of x. And there we have a chain rule, because we have cosine of something that's not just x there. So if we were to sort of box that off, we would have it as f of x. And what we'll get is negative sine of f of x. But then we have to take the derivative of the inside function, so we would just denote that with that f prime of x. And then for the next bit, we need to leave the second function alone, so cosine of f of x, and take the derivative with respect to x of 4 sine of x, and that's going to be 4 cosine of x. And then from there, we want to just solve for that f prime of x. So I'm going to start by subtracting the part without an f prime over, that cosine of x, cosine of f of x times 4 cosine of x. And so we get, I'll pull that negative out, so sine of x times sine of f of x times f prime of x. And that will equal negative 4 cosine of x times cosine of f of x. And now we just need to divide by the sort of coefficient out in front of our f prime there. And we get f prime of x will equal negative 4 cosine of x cosine of f of x over negative 4 sine of x times sine of f of x. And so we've solved for f prime, so now I'm at the point where I want to go ahead and substitute y values back in. So we get y prime equals, and we can clean this up, negative 4 over negative 4 is going to go away. So we get cosine of x times cosine of y divided by the sine of x times the sine of y. And there we get our derivative. For our other problem here, again, we'll start by making our substitution. We'll have e to the f of x times cosine of x equals x plus x times f of x. And we're going to take the derivative of both sides now. And we got a couple of chain and product rules happening throughout here. So for the first part, on the left, we have a product rule, so I'll leave e to the f of x alone, and then the derivative of cosine is negative sine of x. And then we will add the derivative of the first bit, which would be e to the f of x times f prime of x, using the chain rule, and we leave that cosine of x alone. And then on the right, we would have 1 plus, now we have to use the chain rule again, so we'd have x times, and then we have to use the product rule again, so we'd have x times the derivative of f of x plus the derivative of x, which is 1 times f of x. So the first one is leaving the x alone, taking the derivative of the f of x, and the second bit was taking the derivative of x, which is just 1, and leaving the f of x alone. And from here, again, we want to get all of the terms with f prime of x on one side of the equation. So we need to get these two on one side and move everything else to the other. And then we can factor out to get the f prime out of there. And divide by that, and we will get f prime of x equals 1 plus f of x plus sine of x e to the f of x over e to the f of x cosine of x minus x. We've got f prime by itself. We want to go ahead and make our substitutions back in. So we get y prime equals 1 plus y plus sine of x times e to the y over e to the y cosine of x minus x. And there is our derivative. And again, if we just took a quick look at the graph here, this is a rather unusual looking graph that is not a function at all. It fails the vertical line test all over the place. Yet we are able to use our techniques to find the derivative of this implicitly defined function.